All right, we're going to look at another example here of a quadratic function, and this one just a slight change. I have this set up already to where I have the x squared function already graphed. This is the graph that we looked at in the previous video. A little bit bigger version, but same idea. And we're going to alter it now. So instead of just f of x equal x squared, we're going to plot along with it x squared plus 2. Just to see what that plus 2 does to the graph. See how that alters things just by adding a number in there. Okay, so let's fill in our xy table again. This time for the xy table I put x and f of x, so the outputs from the f function are going to go in this middle column, and then I have g of x in the last column as the outputs for the green function over here. So again, this middle function is going to be just like we had before. But then we'll go ahead and we'll make the adjustment by adding the 2 in each one. So if you plug in a 0, 0 squared is 0. But then if you take and do 0 squared plus 2, you would get 2. It's just 2 more than the previous number. If I plug a 1 in, 1 squared is 1. But then if I plug that 1 into the g function, 1 squared is 1 plus 2 makes 3. Again, it's 2 more than the previous column. Alright, I put a 2 in, 2 squared is 4. But in the g function, I put a 2 in, 2 squared is 4 plus 2 makes 6. And you can see how everything ends up getting moved up 2 units, right? Everything's bumped up by 2 units. I can continue this pattern down. 3 squared is 9. But 3 squared plus 2 is 11. Negative 1 squared is 1. And negative 1 squared plus 2 is 3. And so you're going to see the same symmetry we saw before. So I'm just going to go ahead and fill this in. You're going to get the 4 and the 9. And then when you add the 2, you're going to get the 6 and the 11. Okay. So now in green, I'm going to go ahead and plot the points that correspond to the x g of x pairs. So 0, 2, 1, 3, 2, 6, 3, 11, and so forth. All right, so 0, 2 goes on the graph. That's a y-intercept. 1, 3, 1, and then 1, 2, 3. And then also negative 1, 3. I'll go ahead and put that point on. Okay. And then I'm going to have 2, 6 and negative 2, 6. So we go over 2 and then up 1, 2, 3, 4, 5, 6. And over 2 to the left and up 6. Notice that in each of these situations, the previous points are being raised up 2 units. Okay, in all 5 of those cases. And it's going to be the same for the 9 to the 11 as well. So the 9 goes up 2 places to 11. This 9 goes up 2 places to an 11. Okay, and so when I plot this graph, I start again at this low point called the vertex, and we're going to plot this graph through the points that are now showing. Okay, and so what I want you to see by doing this exercise is that each of the points from the original equation get shifted up 2 units. Okay, so there's a shift up here of 2, a shift up of 2, shift up of 2, and so forth. Every one of these points essentially gets moved, and it's going to get real narrow here, but essentially gets moved up 2 units from the original point. Alright, so we have a general principle here that basically says if you add a number to the original function, you shift up that many units. If you were to subtract, you can imagine that it would shift down. It would be reducing each of those values by that amount. And so in general, Let's see, let's go with y equals x squared plus k is a vertical shift. Let's straighten that out. Of x squared by k units. Okay, and again that's going to be so it's going to shift up if k is positive, and it's going to shift down if k is, oops, let's get that on there, shift down if k is negative. Okay, so that's sort of a general principle, going to give this vertical shift whenever you add a number or subtract a number to the x squared. Okay, one other thing that's really important to point out is on this green graph for g of x, the vertex is the point 0, 2. And in fact, in general, the vertex is going to be 0, k, whatever that k value is, because if you start at 0 and shift k units, you end up at k, either up or down, it doesn't matter. Okay, so those are some very important features. One other important feature are the domain and range. The domain stays all real numbers just like we had it before, because you can plug anything in, the inputs don't change, but the outputs do change. And the outputs now, if I look at this specific one for the range, where do I have a little space here, maybe up here? The range starts at 2 and goes up to infinity, rather than starting at 0 like we had before. And so in general, the range starts at that k value and goes up to infinity. Right, so that k value ends up being very important. It's also the value of the y-intercept in this example, but we're going to mainly focus in on the vertex and the range for right now.